Hello friends, welcome to GANZ Sam Tutor YouTube channel. I'm Shamshad and I'm so excited to be with you all today. You know, chemistry can sometimes feel like a big puzzle with all these elements and reactions, but I'm here to tell you, it doesn't have to be that way. Today, we're going to tackle this together. We've got the 10 most important questions for your Class 10 chemistry exam. Questions I know you might be struggling with. Questions that often trip students up. But don't worry, we're going to break them down step by step, making sure you understand not just the answer, but the why behind it. Think of this as your crash course, your secret weapon to ace that exam. So, are you ready? Let's dive in. Alright, let's start with a bang. Our first question is about chemical reactions and equations, specifically those involving precipitation. Imagine mixing two clear liquids together and suddenly, boom, you see a solid forming in the solution. That, my friends, is a precipitate. When barium chloride reacts with sodium sulfate in water, barium sulfate forms as a solid precipitate. The balanced equation is BaCl2AQ plus Na2SO4AQ, BaSO4S plus 2 NaClAQ. This reaction, forming an insoluble product, is called a precipitation reaction. Now, let's move on to acids, bases, and salts. This chapter is all about understanding the properties of these compounds and how they react with each other. And what better way to illustrate this than with a reaction that really heats things up? The question asks what happens chemically when quicklime is added to water. Quicklime, or calcium oxide, CaO, is a white, caustic powder that's been used for centuries in construction and agriculture. But when it comes into contact with water, things get exciting. You see, quicklime has a strong affinity for water. When you add it to water, it reacts vigorously, forming calcium hydroxide, also known as slaked lime, CaOH2. This reaction is exothermic, meaning it releases a significant amount of heat. You can actually feel the heat being generated if you touch the container. The balanced chemical equation for this reaction is CaOs plus H2O L KOH2AQ plus heat. The heat released is a testament to the strength of the chemical bonds being formed. This reaction is used in many applications, from making cement and mortar to treating acidic soil. It's a great example of how a simple chemical reaction can have a big impact on our world. Chapter 3. Let's dive into the fascinating world of metals and nonmetals. This chapter explores the unique properties and reactivity of these elements. Aluminium reacts with steam, forming aluminium oxide and hydrogen gas. Copper, however, remains unreactive with water in any form. This makes copper ideal for plumbing and electrical wiring. Understanding metal reactivity helps us grasp electron transfer and chemical stability. Chapter 4. Let's talk about carbon and its compounds, the building blocks of life as we know it. This chapter is all about the amazing versatility of carbon and its ability to form a vast array of compounds. The question throws us into the world of chemical reactions, asking us to write the balanced chemical equation for the reaction between iron, 3, oxide, and aluminium. This reaction is not just any reaction, it's the famous thermite reaction, known for its spectacular release of heat and light. Imagine this. You mix powdered iron, Ba3, oxide with powdered aluminium. Nothing much happens, right? But introduce a source of high heat and boom, the reaction ignites, producing molten iron and aluminium oxide along with an incredible amount of heat. The balanced chemical equation for this reaction is Fe2O3 solid plus 2Al solid gives 2Fe liquid plus Al2O3 liquid plus heat. The liquid state of iron and aluminium oxide indicates they are in liquid form due to the intense heat generated. This reaction is a classic example of a displacement reaction. where a more reactive metal, in this case aluminium, displaces a less reactive metal, iron, from its compound. It's a beautiful illustration of how chemical reactions can be harnessed for practical applications like welding railway tracks. Chapter 5. Our final question takes us on a journey back in time to the development of the periodic table, a cornerstone of modern chemistry. We're asked to explain the significance of Dmitri Mendeleev's periodic table, a revolutionary concept that shaped our understanding of the elements. Before Mendeleev, elements were being discovered left, right, and center, but there was no systematic way to organize them. It was like having a library with no Dewey Decimal System. Mendeleev changed all that. He arranged the known elements in increasing order of their atomic mass, noticing a recurring pattern in their properties. This led him to create the periodic table, a masterpiece of scientific organization. But Mendeleev's genius went beyond just arranging the known elements. He boldly left gaps in his table, predicting the existence and properties of undiscovered elements. And guess what? His predictions were spot on. Elements like gallium, scandium, and germanium were discovered later, fitting perfectly into the gaps Mendeleev had predicted, with properties remarkably close to what he had foreseen. Mendeleev's periodic table wasn't just about organizing elements. It was about revealing the underlying order of the universe, a testament to the predictive power of science. So friends, those were the 10 most important chemistry questions and their answers, explained in a way that I hope made sense to you. Remember, chemistry isn't about memorizing facts. It's about understanding the why, the how, the amazing interactions between elements and compounds that make up our world. Practice these questions, revisit the concepts, and don't hesitate to ask for help if you need it. I have no doubt that you can ace that exam. You've got the power of knowledge on your side, and that's something no one can take away from you. If you liked this video, hit that like button, subscribe to GANZ Sam Tutor for more awesome content, and share it with your friends. Let's spread the love for learning. Thank you, and all the best for your exams.